If you are new to clinical education or you're about to start clinical education, this video is for you. What I'm going to talk about today is control panel and what we use it for. Generally speaking, just in a short sentence, your control panel is where we control the quantity and quality of x-rays that we create and expose a patient to. There are some other things that we're going to cover on this, but those are the main two things. This is a APR system. It's automatically programmed radiography. And what we do here, what we can do here is just, you see, you have menus on both sides of this: skull, thorax, abdomen, pelvis, upper extremity, lower extremity, spines, and special procedures. So what I'll do is I'm going to push skull, and what we're going to see there is we're going to see a sub menu that gives us the different projections that we might use for skulls. So what you might have noticed is as I push that button, what we got is a change in KVP, MA, and time. MA and time go together to create mass. So we'll talk about that here in a minute. But as I scroll through these, you'll see subtle changes, or may even be not so subtle changes in our technical factors, our KVP and our mass. So I come over here to sinuses, and same thing. If I back out to the main menu and I go to upper extremity, you can see that things are going to change quite a bit. So I've got upper extremity, lower extremity. It should be fairly similar to upper extremity, some differences. But if I come back out and I go to thorax, we're going to see something that may be completely different, like our KVP jumped up to 100 KVP. So on an APR system, what you do is you search for the exam type, and the machine kind of sets itself up for those exam types. If you're not using an APR system, then what you might just see is, instead of the exam types, you'll see KVP, milliseconds, in MA. So on our control panel, what we do is we control the quality of the x-ray beam, and we do that most specifically with KVP. There are other things that affect quality, but KVP is the thing that we use to control the quality of the x-ray beam. Filtration does too. There are videos that I'll record later in the semester, in class, in lecture, and I'll explain that. Okay, so we've got KVP. KVP is the quality of the x-ray beam. MA is the, well, MA in time in seconds, that's milliseconds, gives us our overall mass. So mass stands for milliamperage seconds. KVP is kilovoltage peak, and that's the highest energy that we're going to create. So if we make an exposure with 86 KVP, then the very highest level of x-rays that come out of the x-ray tube should not exceed 86. Now, there is a variance that we'll talk about in quality control later in the curriculum, but that's pretty much what that means. The peak is the highest energy x-ray photon that we create and expose the patient to, and mass should be MA times time in seconds to give us our overall mass. I'm going to scoot this up just a little bit so that we can see our mass. If I wanted to change my mass value, I could change either MA or time, and if you notice, we've got two mass here. 200 MA times 10 milliseconds gives us 2 mass. If I wanted to increase my mass, I could increase MA, so it goes up to, that's tube limit here, but we've got 3.2 mass just by increasing our MA. What we could also do is increase our milliseconds, and that also gives us a higher mass value. So we can arrive at higher mass values by manipulation of either MA or time, or even a combination of the two. So if we wanted to make an exposure with very short exposure time, what we would do is increase our MA. So we've got an increase in mass without an increase in our exposure time. If we wanted to have the same overall mass, as I increase my MA, I'm going to go to 250 MA, then I could reduce my time, and I've gone back down to 2 mass. So we can use MA and time to affect a change, giving us the same mass being a measure of quantity of x-ray photons. We've got the same mass with a shorter exposure time. The benefit to that is that if the patient's moving, if you have a pediatric patient or a patient who has Parkinson's or some sort of condition where they can't be still, then that gives you the option to use a shorter exposure time to limit the amount of motion that's going to be seen on the image receptor. So KVP again is power. The power of the X-ray beam, that's the penetration of the X-ray beam, is the inside the X-ray tube. It's the potential difference in how fast the electrons move across the tube. And mass is an overall count of X-rays that we create. This machine gives us the option of selecting MA and time separately. You can have a mass calculation where you just do one. And in this case, what you've got is a situation where you can't control the MA. It's giving you a set MA, and you can adjust your time to affect a change in overall mass. So what you might have picked up on before is that as I increased my MA to a point, it got to what that says tube MA limit. So the reason we're at tube limit is because we're on small focal spot. So the focal spot is the filament from which all of the electrons emanate before we send them across the X-ray tube. And a small filament is just that. It's kind of like in a light bulb. It's a very small filament. And it can only hold so many electrons, and adding any more electrons to that would actually cause potential tube damage. Just like a light bulb, the X-ray tube can burn out. Our large focal spot can handle more. So if I switch over to large focal spot, look what happens. I can increase my MA significantly more, all the way up to the tube limit on this one is 710 MA. So our large focal spot, we can utilize a higher MA setting. Our small focal spot is MA limited, and that's protection for the X-ray tube, so you don't try to use too much MA on a small focal spot. I changed my setup just a little bit, and what I did was I set the machine up for a chest X-ray. So I set my computer up for a chest X-ray, and that overrode the settings on my control panel. So what I did was I went to just quick start. We're not really taking an X-ray on anybody, so I just went to quick start here, and I selected chest X-ray. That's the first thing that you're going to learn about, most likely in your clinical education and also your class. So what we have then is once I click on chest X-ray, if I clicked on upper extremity, you can see the secondary menu is totally different. So I clicked on chest X-ray. Your most common routine is going to be a PA and a lateral. So I'm going to click PA. So I click PA and click this button over here, and it says Start Study if you can't really make that out on your computer screen, certainly on your phone screen, but that says Start Study. So I click that, and it brings me up to this. What that also does is it changes everything on your console. So you'll notice then that you've got a few other things activated. So you've got, it's on AEC, that stands for Automatic Exposure Control. It's at your KVP and it's at your MA, and notice that you don't have anything except for MA. You don't have time. And that's because you're going to be using AECs. So what these things are, that's your AEC field, and we'll take a look at how that looks on the wall bucky here in a minute. But what those are is radiation detectors. Those are representative of the radiation detectors on the wall bucky. So you can change these. You can select center cell, you can select outer cells only, or you can select any configuration of those. What they are is inside of the wall bucky, it's a radiation detector that automatically turns off the exposure once the proper amount of radiation is selected. So your MA is set, so fundamentally what that does is it sets your time, so you get an overall mass value. Now, I'm not shooting into anything, so this is going to be very low exposure, but I'm going to go ahead and make an exposure. And you can see that your total mass there was 0.6. If I had a patient in front of it, your KVP would remain the same, and what would happen is you would have a higher mass value. One of the first things that you need to do in clinicals is to familiarize yourself with this control panel. You need to see how you can adjust KVP. You need to see how you can adjust MA. You need to see how you can adjust time. You need to see how to turn on AECs. You need to understand where you're shooting, be it into a table bucky or wall bucky, or non-bucky would be a tabletop technique. You need to see how to adjust focal spot size. You also need to understand the buttons for making an exposure. So you've got two different buttons here. One is prep, and what the prep does is it turns the rotor, and I hope you can hear this. So what that's doing is it's turning the anode. So as soon as you push the prep button, what happens is the anode starts to spin. You're not making x-rays whenever you push the rotor button. It's not until you press the exposure button that you make an exposure. Now you have mass. So our total mass here is 0.8. I didn't set anything in front of the bucky, so we just shot air essentially. So we have very low mass. It's 0.8 mass. If you were to push the exposure button all by itself, notice what happens. You notice you had about a second delay before our exposure was made. And the reason for that is that because what has to happen to protect the x-ray tube from excessive exposure and heat is that we have to have that rotor spinning up, and it goes from 0 to 3,000 RPMs in about a second. So if you listen as I push the prep button all by itself, about a second delay. I get off of that and I push it again, just the exposure, and it took about a second before we made the exposures. So there's another button that's here as well, and this is a 2-position button. So if I push down just this top button, that's a rotor. So I can spin that all day long. I'm just creating a lot of heat, and it's bad for the x-ray tube. But I didn't make any x-rays. If I push it down and wait that second, now I can make an exposure. Also, if I just push this straight through, again, notice it takes about a second to get up to speed before it'll make an exposure. So again, your KVP, your MA, if we are not phototiming, that's what AECs are. These things are what we refer to as phototimers, and they're just radiation detectors that are in the bucky that set the time according to how much radiation they receive. So if I were to put something in front of the wall bucky and shoot again, then they would stay on longer, give me a higher mass value. So AECs, automatic exposure control, that's these things. These are radiation detectors. With a lot of time we'll refer to them as photocells, phototimers, things like that. There are different configurations for that as well. So you can select the table bucky, the wall bucky. Non-bucky would be tabletop. You can select focal spot size. That's really pretty inconsequential for right now. You can select your KVP. You can select your MA. So if you needed a longer exposure time for whatever, chest x-ray, you're never going to need a long exposure time, but you could decrease your MA, which would automatically cause your time to increase. So there are exams where we want long time, but most of the time we want short exposure time. It's really important to understand the control panel and what it is that you're doing at the control panel, so that when the technologist that you're working for says go set up for a chest x-ray, you need to know what that looks like. So most of the time your machine, your computer is going to control your control panel, but there are times that you can use control panel itself to set those things up. What you need to know are the KVPs for specific exams, the KVP levels for specific exams. For chest x-rays, it's always going to be about 110 to 120 KVP, depending on the protocol and machine you're shooting with. You need to know what the individual buttons are for. So prep just heats the filament and spins the anode. Expose is where we actually make x-rays. So if somebody says get on the rotor, that's what they're talking about, is a prep button. Hit the prep button. Sometimes if you have a baby and you're trying to take a chest x-ray on a baby, what you need to do is you need to hold that prep button down and wait for the baby, who's probably crying, to make that inhalation before you make your exposure. So you need to know when it's appropriate to have a long prep time. It's rarely appropriate, but sometimes it is. And then you also need to know that you can't just jump onto the exposure button and expect to have an immediate exposure. It's for safety purposes for the x-ray tube. It's going to limit you to an exposure after that 1 second after the rotor gets up to speed. Same thing with this button here. So where you would utilize this, a button like this is sometimes on portables. This gives you a little bit more room, a little bit more distance to get away from the patient, step out of the room to make your exposure. In an x-ray room, that needs to be pretty short. You don't need to be standing out in the room with a button in your hand. You need to be making your exposure in the exposure booth in the console area. It's radiation protected. We've got windows that are leaded glass. The entire booth is leaded so that x-rays won't get to you. Also, there's an emergency cutoff right there.